Hello, I'm going to try to help you out with your problem. And if you look at the polynomial over here that you entered in, or that you gave me, I entered it in, and you can do it on your calculator as well. So this is a fourth degree polynomial. We have 1x to the fourth, or just x to the fourth, plus 6x cubed, plus 7x squared, minus 6x, minus 8. So this is that polynomial that you sent me, the one with the fourth degree with 5 terms. And essentially there's a process that we can use to go through this. So the first thing that I would do is this rational zero theorem. So you might remember it with your P's and Q's. Essentially what it says is that if you have zeros of a polynomial with real coefficients, then you're going to take the ratio of all the factors of P over all the factors of Q, where P is that constant term, and Q is the leading coefficient. So we're going to do all the factors of P over all the factors of Q. Well, our P is -8, so we can think of that as 8. And the factors of 8 are simply 1, 2, 4, and 8. The factors of Q is 1, so there's only one factor of Q, and that's 1. So essentially, all the rational zeros will be either plus or minus 1, 2, 4, or 8, all divided by 1. So that is going to be the list of the possible zeros there. That's what I do first. So we call that the rational zero theorem. The rational zero theorem. So that's what I would do first. Okay. So now that we have a list of those possible rational zeros, the plus or minus 1, 2, 4, and 8, what we're going to do is we're going to plot the polynomial. So you can use your calculator to do this. I'm using Desmos, but your calculator, go into y equals and plug in x to the fourth plus 6x cubed plus 7x squared minus 6x minus 8. And when you look at the polynomial, you'll sort of see where those zeros might be. So I see 1 might be around here, probably at 1. I see 1 might be around here at -1. And I see 1 might be at -2, and I see 1 might be at -4. So actually, all these are on the list. So I'm thinking that those would be your zeros. However, all we really need to do is find 2 of them, because if we find 2 of them, we can divide them in and get a quadratic, which we can solve. So I'm going to show you that process here. So essentially, I think we found them all, but I'm going to show you how to find them if 2 of them, let's say, were imaginary, so we couldn't see them crossing the x-axis, or if 1 was repeated, or if 1 was not rational, like plus or minus square root of 2 or something like that. So what I'm going to do is use just divisions. I'm going to use synthetic division. So I'm going to put my coefficients down here. I'm going to leave some space. I'm going to do 1, 6, 7, -6, -8. And those are my coefficients. Now, if I had a 0, I'd want to put in a 0 there, but I don't. So I'm good with those 5 coefficients. Now, I'm going to divide by a possible 0. So we thought there might be 1 over here where x is equal to 1. So I'm going to try that. So I'm going to guess, well, 1 might be at 1. So we'll try that. What if 1 is at 1? We'll see. So I'm going to use this synthetic division. In synthetic division, I bring that first 1 down, and I multiply it by the 1. So I get a 2. I add the 6 and the 2. I get 8. I take the 8 times the 1, and I get 8. And then I add the 7 and the 8. I get 15. I multiply the 15 by 1. Of course, that's 15. And when I add, I get 9. So I've done something wrong here. Let's check this out again. So I bring down the 1. When I multiply 1 and 1, I don't get 2, do I? I get 1. Sorry about that. So 6 plus 1 is 7. And 7 times 1 is 7. Now this is 14. 14 times 1 is 14. And now I add and I get 8. And 8 times 1 is 8. And when I add those, that 8 and negative 8, I get a 0. So that 0 at the end is a remainder. It says that, yes, x equals 1 is a 0. But it not only tells us that, it also tells us that we have a new polynomial here. So my new polynomial would be, let's see if I can get this down here. It's going to be 1 times x cubed now, plus 7 times x squared, plus 14x plus 8, and then the remainder was 0, which told us this was a 0. So now I'm going to use this new polynomial and try again. So it looks like negative 1 might be a 0 as well, right? So I'm going to copy down those coefficients. So I have 1, 7, 14, and 8. I'm going to try with negative 1. So we're going to see if that's a 0. So I'm going to use synthetic division again. I'm going to bring down my 1. 1 times negative 1 is negative 1. I add 7 and negative 1 and get 6. So I have negative 1 times 6. That is negative 6. Add those together, and I get 8. And 8 times negative 1 is negative 8. I add those together, and I get 0. So we found out that x equals negative 1 is a 0. And that's what we wanted. All right. So I told you you only had to do this 2 times for this one because what we have left is a quadratic, and we know how to solve quadratics. That's why it was important to know the quadratic formula or factoring. So we have an x squared plus 6x plus 8. So that's our last polynomial. So if we want to find where it equals 0, we can sort of see that from the polynomial over here, the graph of it, it's going to be at negative 2 and negative 4. But let's just go ahead and verify that. So I would do x and x here. And I need 2 factors that multiply to 8 and add to 6. Well, 2 and 4 fit the bill. And we can sort of verify it by the graph. So graphing it is fairly important. So now we know that if we set each one individually equal to 0, that x equals negative 2 and x equals negative 4 are the other zeros. And by the way, from the fundamental theorem of algebra, we knew right off the top that there were going to be 4 zeros because that was our degree. So we knew right off the bat that there were going to be 4 zeros. And that's important because that will tell us when to stop. We can stop. Okay, so I probably should have added that in right off the bat. All right, let's see where we're at. So it looks like I got these covered up here. So that's really the end of the problem. So for this one, we have x equals negative 2, negative 4, negative 1, and 1 are the 4 zeros. And again, you can verify that on your graph by just looking at the graph here. So we see one here, that's your negative 4, and that's your negative 2, and that's -1, and that's your +1. So having the calculator at this point sort of comes in handy. If these zeros weren't so nice after we divided, we probably want to use like the quadratic formula or something like that. All right, well, I hope this has helped you out. Thanks.